In this video, we'll go over the solution to the two problems that are posted on Moodle for homework. In the first problem, we're asked to determine the amount of heat that's required to convert 10 grams of ice at negative 20 degrees Celsius to water vapor at 150 degrees Celsius. For this process, we're going to need to warm the ice, then melt the ice, then warm the water, then vaporize the water, then warm the water vapor. So there will be many steps to this problem. To get the total amount of heat that's required, we're just going to sum up the amount of heat required for each step. For these problems, it's often convenient to look at the heating curve and use it as a guide to tell us how many different values for Q, meaning how many different steps we will have. Here's a sketch of a heating curve. The heating curve, again, is temperature as a function of the amount of heat that's added, and we can see there are 5 distinct portions to the heating curve. The first one involves an increase in temperature as we're adding heat and warming the solid. Then we have a constant temperature while the heat that's being added is melting the solid. When the melting is complete, the temperature again increases as we add heat to the liquid until we reach the boiling point, at which point the temperature does not change and the heat that's added goes to vaporization. And then finally, once vaporization has occurred, we can change the temperature of the vapor if we continue to add more heat. So for these general types of problems, it's good to find the place on the heating curve that you're beginning and the place that you're going to end, so you see how many different values of Q, or heat, you need to calculate. So we're starting at negative 20 degrees Celsius, which for water would be below the freezing point. So we will be starting somewhere in this portion of the curve as a solid. Where are we ending? We're ending with water vapor at 150 degrees Celsius. That's above the boiling point of water, so we'll be ending somewhere in this region up here. Once we know where we're beginning and ending, we know how many separate steps we have. So we are going to heat the solid, we're going to melt the solid, we're going to heat the liquid, we're going to vaporize the liquid, and we're going to heat the vapor. So we will have 5 steps, 5 distinct values of heat, or Q, that we need to calculate in this problem. Again, to get the total amount of heat that's required, we're just going to sum up the values of these 5 heats. So our first value for Q involves changing the temperature of the solid. So when the temperature is changing, we determine the amount of heat using Q equals mc delta T. We do this as a plug and chug. So let's see if we can find the values to plug in. The mass is given in the problem. The mass is given right here. Where do we get the specific heat for ice? Well, this isn't a number that you would have to memorize. On an exam, it would be given to you. For homework, you can look it up in the book. And what we find is that the specific heat of ice is equal to 2.06 joules per gram degree Celsius. Now what about our change in temperature? A lot of students are tempted to think that the temperature change is from negative 20 degrees Celsius to 150 degrees Celsius, but that wouldn't be correct. Remember, in this particular step, we are only warming the ice up to the melting point for water, which is 0 degrees Celsius. So our final temperature is 0 degrees Celsius. Our initial temperature is negative 20 degrees Celsius. So delta T would be 20 degrees Celsius. Now we're ready to go ahead and plug and chug. We have 10 grams of ice. We have our specific heat that we looked up. And we just calculated our delta T. So we put that into the calculator and we get an answer of 412 joules. A quick look at my digits tells me I have 2 digits in the answer. So now let's move on to Q2. What's happening after we heat the ice? The ice is going to melt. So how do we solve problems that involve phase changes? We do those as a unit conversion, and of course the bridge that we need to use would be the heat that corresponds to whatever our phase change is. So in this case we're melting. Of course the fancy word for melting is fusion. So we're going to start with the amount that's given. Again, the amount that's given is the 10 grams of ice. So we're going to start with 10 grams of ice. And we need our heat of fusion in order to convert. Again, this is a number that we're going to have to look up. And when we do that, we see that the heat of fusion for ice is equal to 333 joules per gram. So that's the number that I'm going to use as my bridge, 333 joules per gram. And of course I put this in the calculator and I get 3,330 joules. Moving on to the third amount of heat that we need. We've already warmed the ice, we've melted the ice. Now we need to change the temperature of the water. So again, when we are looking at a problem involving a temperature change, we do a plug and chug. Q is equal to mc delta T. My mass is given. My specific heat for water, by now you're probably familiar with this, is 4.184 joules per gram degree Celsius. Remember, in a problem involving a change in temperature, Kelvin and a degree Celsius are the same. There's no need, and in fact you'll get the wrong answer if you can try to convert a delta T. So mc and delta T, what is delta T? Well, remember, we're just warming it, not the entire way from negative 20 degrees Celsius to 150. We're just, in this step, heating the water from its melting point of 0 degrees Celsius to its boiling point of 100 degrees Celsius. So delta T is 100 degrees Celsius. And of course, this will give us 4,184 joules. Moving on to Q4. We're ready to vaporize the water, and of course the bridge that we need for that is the heat of vaporization. And we do this as a unit conversion, so we start with the amount that's given, which of course is the 10 grams. And now we need to look up the heat of vaporization for water. The value that we find, however, is given to us as 40.65 joules per mole. This is the first of these values that it's been given to us in terms of moles instead of grams, but that's okay. We know how to do a unit conversion. So since the unit for amount in my bridge is the mole, but the unit that I'm given is grams, before I can use the heat of vaporization, I need to convert to moles. And of course, what converts from grams to moles? That's the molar mass. So we need grams of water on the bottom, moles on the top. Now we can use our bridge that's given. And I also see that all of my other values have been in joules, but this one is given to me in kilojoules. Yes, I'll correct that right now. So we're going to go ahead and put it into joules in our bridge. So we have 40,650 joules per mole. Now all of our units are working for us. So we put this in the calculator and we get 22,563 joules. And a quick look at that gives me 3 digits. Moving on to my fifth and final value for Q, all that's left to do is to increase the temperature of the water vapor. So when we're increasing temperature, we do that as a plug and chug. Q is equal to mc delta T, which means we need to go look up the value for the specific heat for water vapor. And when we do that, we see that it has a value of 1.966 joules per gram degree Celsius. Now we're ready to plug into our equation, our mass, 10 grams, our specific heat, 1.966 joules per gram degree Celsius. And what about delta T? Well, we started at 100 degrees Celsius after the water had been vaporized, and we're going to 150 degrees Celsius, so delta T is 50 degrees Celsius. And when we put this into our calculator, we get a value of 998 joules. And our final step to get Q total is to just sum the values that we got for Q1 through Q5. And looking back on previous pages, we see that these values are 412 joules plus 3,330 joules plus 4,184 joules, 22,563 joules, and finally 998 joules. Which gives us, of course, 31,600 joules, or 31.6 kilojoules. In our second problem, we're asked how many grams of ethanol must be vaporized in order to absorb 78 kilojoules of heat. So in this problem, we are only working with one Q. That is a Q for vaporization. Remember, when we are calculating a Q for a phase change, we do these as a unit analysis, and of course our bridge is the heat of whatever the phase change will be. So for vaporization, we need to go look up the heat of vaporization for ethanol. And when we do that, we see that delta H vaporization is given as 38.56 kilojoules per mole. Now that we have our bridge, we're ready to do our unit conversion. So of course we always begin with the amount given. So in this case the amount given is these 78 kilojoules. We look up here at our bridge and we see that our bridge will go from kilojoules to moles, so let's go ahead and do that. Of course, what do we need on the bottom to cancel is the kilojoules, so 38.56 kilojoules in the denominator per mole. But of course, we look up and see that we were asked for grams, not moles, so we also have to convert our answer from moles into grams, and of course the molar mass is what does that. Now we'll just double check that our units are working for us. And certainly there are. We're left with grams, which is what we were asked for. And so when we put this in the calculator, 2 digits in our answer, we get 93 grams of ethanol.